Question 1. While examining a chilled water plant's seasonal performance, an HVACR engineer notices that despite high efficiency during peak load periods, the energy bills remain unusually high during shoulder seasons. The system uses multiple chillers and VFD pumps, yet the IPOV appears inflated. What is the most plausible root cause of the misleading IPOV value? A. The system was oversized, causing inefficient part load operation during low demand periods. B. The COC was calculated under maximum load conditions rather than seasonal load variations. C. The chiller's condenser water loop was incorrectly sized for summer design conditions. D. The building's load profile was modeled without accounting for internal heat gains. Answer. Correct answer. A. Explanation. IPOV integrated part load value assumes idealized load percentages and does not always reflect real-world diversity in load profiles. Oversized systems often cycle inefficiently during low loads, degrading true seasonal performance despite appearing efficient on paper. This overstates IPOV, which ASHRAE 90.1 cautions against relying on solely. Ref. ASHRAE STD 90.1. RO 550-590. Question 2. In the context of energy-efficient control strategies for a VAV variable air volume HVAC system in a mid-rise commercial building, which method best improves occupant comfort while reducing energy use? A. Using fixed discharge air temperatures to stabilize zone temperatures. B. Implementing DC-based demand-controlled ventilation with co-sensors. C. Utilizing manual dampers with scheduled overrides during occupancy hours. D. Bypassing VAV boxes during unoccupied periods to keep fan operation constant. Answer. Correct answer. B. Explanation. Demand control ventilation DC-V with DEC and co-sensing optimizes outdoor air intake based on actual occupancy, minimizing energy use while maintaining IAC. Fixed temperature controls and manual dampers are outdated and wasteful. ASHRAE 62.1 supports DC-V strategies as best practice. Question 3. Taking into account a large healthcare facilities renovation project, HVACR engineer Ista Bhattacharya is tasked with recalculating cooling loads. The original building design used R11 glazing and 20-year-old lighting. New upgrades include LED fixtures and lower windows. Which factor should be treated most critically in his new cooling load analysis? A. Reduction in lighting heat gain. B. Increased occupancy in waiting areas. C. Air infiltration through renovated exterior walls. D. Change in internal equipment usage. Answer. Correct answer. A. Explanation. Lighting contributes significantly to sensible internal heat gain. Upgrading to LED lighting drastically reduces heat input, impacting cooling load more than minor infiltration or equipment changes. The ASHRAE Handbook. Fundamentals confirms lighting as major internal load factor in commercial cooling design. Question 4. From a practical standpoint, when designing a duct system for a mixed-use facility with retail on the first floor and offices above, what is the most critical design consideration to ensure both air balance and acoustic comfort? A. Selecting ducts based on velocity pressure alone. B. Designing duct trunks for constant static pressure. C. Incorporating flexible ducts throughout to reduce transmission noise. D. Applying different static regain methods based on floor use. Answer. Correct answer. D. Explanation. Mixed-use zones require different airflow and noise control strategies. Static regain calculations must be tailored to occupancy type to maintain air balance and minimize noise transfer. SMACNA duct design manual supports using variable static regain approaches in multi-use applications. Question 5. Given the circumstances, O'Connor is retrofitting hydronic radiant heating system into historic library with strict humidity and temperature controls. Which key factor must she consider to ensure long-term system performance without damaging historic materials? A. Minimize water temperature to 100 Fortide to reduce heat stress. B. Install high thermal mass floors to ensure even heat distribution. C. Use open-loop systems to avoid water stagnation. D. Include zone valves to rapidly adjust temperatures during load spikes. Answer. Correct answer. B. Explanation. High thermal mass improves radiant system stability and avoids rapid fluctuations that could damage sensitive materials. Open-loop systems risk corrosion, and 140 may still be too hot. Radiant designs per ASHRAE handbook. HVAC applications stress thermal inertia and humidity control. Question 6. Contrary to popular belief, selecting a refrigerant solely based on TBOE or guarantee sustainability in a commercial refrigeration project. What additional consideration is most critical for compliance and long-term viability? A. Availability of reclaim recycle infrastructure. B. Operating pressure of the refrigerant. C. Compatibility with existing compressor types. D. Regional climate conditions. Answer. Correct answer. A. Explanation. Even DOPA refrigerants can face life cycle issues if reclaiming infrastructure is absent. EPA Section 608 and Kigali Amendment stress life cycle environmental impact. Not GDPU, long-term availability and serviceability are essential. RAF, EPA 40 CFR Part 82 Subpart FRA Guidelines. Question 7. During the process of sizing a chilled water loop for a data center, Mr. Yamaguchi calculates a velocity of 12 feet in a supply pipe. What is the most pressing concern with maintaining this velocity? A. Increased laminar flow reduces turbulence and mixing. B. Cavitation in control valves becomes significant. C. Noise and erosion in pipes due to high velocity. D. Low Reynolds number impairs system response. Answer. Correct answer. C. Explanation. Velocities above 10 feet in chilled water systems often cause pipe erosion and noise, especially at bends or fittings. ASHRAE recommends equals 8 feet for design. Cavitation is typically concerned in pumps, not on straight piping at this velocity. RAF, ASHRAE Handbook, HVAC systems and equipment. Question 8. In light of recent developments, an engineer evaluates the use of ECM motors over PSC motors in large air handlers. Aside from energy efficiency, which advantage most justifies ECM motor implementation in modern control systems? A. Lower inrush current at startup. B. Simpler wiring with fewer terminals. C. Higher tolerance for voltage imbalance. D. Integrated variable speed control with feedback. Answer. Correct answer. D. Explanation. ECM electronically commutated motors offer integrated variable speed and feedback control, enabling precise airflow adjustments through BAS. This improves efficiency and IAC. ASHRAE 90.1 promotes ECMs in variable air systems for enhanced control. PSC motors lack feedback capability. Question 9. Through careful analysis of a manufacturing plant with intermittent high contaminant loads, Mr. Delgado is tasked with designing a ventilation system. Which design feature is most critical to ensuring compliance with IAC regulations and minimizing energy loss? A. Fixed outdoor air dampers with high-efficiency filters. B. Heat recovery ventilators with variable exhaust rates. C. Fully open exhaust fans during peak production. D. Dedicated make-up air units with constant speed drives. Answer. Correct answer. B. Explanation ARVS with variable exhaust offer IAC compliance per ASHRAE 62.1 and reduced heat and cooling penalties by reclaiming energy. Fixed dampers waste energy and constant speed mouse lack responsiveness. Smart exhaust matching improves both efficiency and air quality. Question 10. The growing trend in HVACR engineering is integrating geothermal heat pumps into mixed-use buildings. What is a significant engineering challenge in such systems that affects long-term performance and code compliance? A. Matching borehole depth with indoor humidity control. B. Maintaining thermal balance in the ground loop over time. C. Regulating refrigerant mass flow with variable loads. D. Choosing between DX and water-to-water system types. Answer. Correct answer. B. Explanation. Thermal imbalance in the ground loop, excessive heat rejection or absorption can degrade performance over time. ASHRAE 34 and HVACR guidelines stress the need for annual thermal balance modeling to avoid loop temperature creep. Improper balance leads to long-term inefficiencies. Question 11. By comparing the energy audit results of two similar-sized commercial buildings, engineer is Torres notices one building consistently shows high UE energy use intensity despite having newer HVAC equipment and LED lighting. What is the most likely contributor to this discrepancy? A. Inefficient scheduling of HVAC operation and lighting. B. Use of valve systems instead of constant volume systems. C. Poor envelope insulation despite internal upgrades. D. Lack of heat recovery systems in domestic hot water design. Answer. Correct answer. A. Explanation. New equipment alone doesn't ensure efficiency. Improperly scheduled HVAC and lighting operations can waste energy during unoccupied hours, inflating the UE. ASHRAE 90.1 and 100 emphasize operational scheduling as critical efficiency factor. VAV typically saves energy, and envelope insulation has lesser impact compared to system runtime. Question 12. Examining the consequences of improper maintenance, Mr. Jeffries discovers that a service technician vented refrigerant directly to the atmosphere while replacing a faulty compressor. Which of the following best describes the technician's violation? A. Minor infraction if the refrigerant was non-ozone depleting. B. Acceptable if the system was no longer in service. C. Violation of EPA 608 rules, regardless of refrigerant type. D. Permitted only for low-pressure appliances during recovery delays. Answer. Correct answer. C. Explanation. EPA 40 CFR Part 82 Subpart F prohibits venting of any refrigerant EFER, either the refrigerant is ozone depleting or not. Direct venting is unlawful and subject to penalties. Recovery is mandatory even for systems being decommissioned. Question 13. Among the various methods of improving refrigeration cycle-efficiency, which action most directly enhances the coefficient of performance (COP) without altering refrigerant type or compressor configuration? A. Increasing superheat in the evaporator. B. Lowering condensing temperature. C. Raising suction pressure. D. Adding subcooling to the condenser outlet. Answer. Correct answer. B. Explanation. Low condensing temperature reduces compressor work for a given refrigerant mass flow, directly increasing COP. This aligns with the first law of thermodynamics and real vapor compression behavior. ASHRAE Fundamentals shows how lower condensing temps significantly boost efficiency. Question 14. To better understand complex supermarket refrigeration design, engineer Mr. Simons evaluates the use of cascade systems. What is the primary reason for selecting a cascade system over a single-stage system in such applications? A. To simplify control strategy across multiple refrigerant circuits. B. To reduce cost by using fewer compressors. C. To manage low and ultra-low temperatures efficiently with staged compression. D. To eliminate the need for defrost cycles in display cases. Answer. Correct answer. C. Explanation. Cascade systems allow separation of low and medium temperature loads using different refrigerants optimized for each stage. This increases efficiency and system stability in commercial refrigeration. ASHRAE Refrigeration Handbook supports this for deep freezing and staged systems. Question 15. Under the assumption that an office tower is experiencing a consistent temperature control and high humidity levels during summer, what is the most appropriate corrective action if the HVAC uses constant volume reheat systems? Say, increase outdoor air intake to dilute humidity. B. Replace reheat coils with modulating dampers. C. Install variable speed drives on supply fans. D. Convert to VAV systems with terminal reheat and humidity control. Answer. Correct answer. D. Explanation. VAV systems with reheat and humidity control allow better part load control, avoiding overcooling and excessive reheating. Common problems in constant volume systems. The ASHRAE 90.1 discourages constant volume reheat due to energy penalties. VAV offers zoning and better humidity control. Question 16. What would happen if an engineer selects an oversized air-cooled chiller for a hospital project based solely on peak summer load without considering part load behavior? A. Energy usage would be reduced during peak hours. B. Part load performance would improve due to larger surface area. C. Compressor short cycling would degrade efficiency and equipment life. D. Lower initial costs due to smaller auxiliary equipment. Answer. Correct answer. C. Explanation. Oversized chillers run inefficiently at low loads, causing frequent compressor cycling, poor dehumidification, and increased wear. This contradicts ASHRAE recommendations to size chillers for near-optimal IPLF. Part load optimization is key to lifecycle performance and reliability. Question 17. Focusing specifically on building automation systems, BAS in large campuses, which feature of BAS contributes most to achieving energy savings while maintaining operational reliability. A. Cloud-based dashboards for real-time viewing. B. Override capabilities for individual zones. C. Centralized data logging and fault detection. D. Manual set points for weekend schedules. Answer. Correct answer. C. Explanation. Fault detection and diagnostics (FDD) with data logging identify inefficiencies, faults, or deviations early, improving system uptime and energy use. ASHA GPC 36 promotes automated fault detection within BAS as a best practice for large-scale HVAC operations. Question 18. Considering the evidence Lefevre is reviewing the chilled water piping layout of a high-rise building and notes that reverse return piping was used instead of direct return. What is the main advantage of this design? A. It reduces pump head by balancing all branches automatically. B. It simplifies pipe routing in buildings with limited riser space. C. It allows for higher flow rates without increasing pipe size. D. It ensures each coil receives the same pressure differential. Answer. Correct answer. D. Explanation. Reverse return systems inherently balance pressure drops across branches, reducing the need for balancing valves. Each path has approximately equal length, ensuring uniform flow. ASHRAE HVAC systems and equipment handbook supports reverse return for large, multi-zone buildings. Question 19. While it is true that cleanrooms require tight temperature and humidity control, which design factor is most crucial in maintaining ISO classification in a pharmaceutical cleanroom? A. High-efficiency filters on exhaust ducts. B. Positive pressurization relative to adjacent spaces. C. Use of radiant heating instead of forced air. D. Exhausting or return air without recirculation. Answer. Correct answer. B. Explanation. Positive pressurization prevents infiltration of unfiltered air, preserving particle count. Requirements. ISO 14644-1 emphasizes pressure control, airflow patterns, and filtration. Exhausting return air is energy intensive and unnecessary when proper pressurization and HEPA filtration are in place. Question 20. The predominant theory suggests that HVAC system performance degradation over time is more influenced by which of the following factors than equipment aging? A. Operating outside of design conditions. B. Manufacturer defects in compressors. C. Sudden power fluctuations. D. Frequent changes in occupancy schedules. Answer. Correct answer. A. Explanation. Long-term performance is most affected by operation outside design parameters, oversizing, poor maintenance, incorrect set points, rather than simple aging. ASHRAE operational guides stress that degradation is often due to system misuse or maintenance neglect, not component lifespan. Question 21. The foundation of HVAC system safety is often embedded in how electrical components are designed and installed. What is the most critical requirement for ensuring compliance with the National Electrical Code (NEC) in mechanical rooms? A. Running control and power circuits in the same conduit. B. Installing disconnect switches in adjacent rooms to reduce costs. C. Ensuring serviceability with accessible clearances for electrical equipment. D. Using low voltage wiring throughout to minimize conduit requirements. Answer. Correct answer. C. Explanation. NEC Article 110 mandates that all electrical equipment be readily accessible for service without removing building structures or walls. Accessibility and working clearance are safety critical. Running power control together is limited, and placing disconnects remotely violates NEC 440.14. Question 22. A detailed analysis of a Duis F-top unit revealed coil frosting issues during mild ambient conditions. What is the most likely design-related cause for this symptom? A. Improper refrigerant charge and oversaturation of the coil. B. Low ambient lockout not integrated with economizer operation. C. Faulty reversing valve in heat pump mode. D. Oversized evaporator coil causing low velocity and reduced heat exchange. Answer. Correct answer, D. Explanation. Oversized coils can lead to low air velocity and heat transfer inefficiency, causing coil surface temperatures to fall below dew point and freeze. The ASHRAE guidelines stress proper coil velocity 35045 ton to prevent frost in DX systems. Question 23. With the advent of building integrated photovoltaic (BIP) systems, with HVAC design consideration is most critical to ensure net zero performance in commercial buildings. A. Sizing equipment for nighttime occupancy loads. B. Using packaged rooftop systems to reduce wiring complexity. C. Integrating thermal storage or load shifting strategies. D. Replacing all VAV systems with fan coil units. Answer. Correct answer, C. Explanation. Net zero performance requires aligning energy demand with renewable generation, thermal storage and load shifting, e.g. pre-cooling or chilled water tanks, reduce grid dependence during non-solar hours. ASHRAE Standard 189.1 supports load management for NZE targets. Question 24. In what ways can using variable primary flow in chilled water systems reduce energy consumption compared to primary-secondary configurations? A. By eliminating the need for bypass valves and decoupler piping. B. By reducing pressure drop across chillers at all load conditions. C. By maintaining constant differential pressure across coils. D. By forcing pumps to run continuously to avoid surge. Answer. Correct answer, A. Explanation. Variable primary flow eliminates redundant secondary pumps, piping, and energy losses in bypass loops. Per ASHRAE HVAC Systems and Equipment Handbook, modern controls stabilize flow to chillers and coils, improving energy use compared to traditional dual-loop systems. Question 25. Throughout the course of planning a refrigerant retrofit for an R22 system, Isel Hassan considers using R438er. What factor must she most critically evaluate to maintain system capacity and avoid compressor failure? A. The compatibility of the expansion valve with high diplo refrigerants. B. The reduction in oil return due to alter viscosity. C. The difference in discharge line size required for new pressure. D. The global availability of R438 beyond 2030. Answer. Correct answer, B. Explanation. R438 has different miscibility and viscosity, which affects oil return in older mineral oil systems. Improper oil return leads to compressor damage. EPA guidelines require oil management and compatibility checks before retrofits. Ref. EPA SNAP program and ARI guideline N. Question 26. From multiple perspectives, what is the primary performance advantage of using chilled beam systems over traditional VAV reheat systems in commercial office buildings? A. Increased latent cooling capacity and simplified ductwork. B. Decoupling of sensible and latent loads, improving efficiency. C. Ability to operate at higher supply air temperatures without stratification. D. Greater dehumidification performance during off-peak hours. Answer. Correct answer, B. Explanation. Chilled beam systems decouple latent cooling handled via DOAs and sensible cooling via beams, improving energy performance by minimizing reheating and fan power. ASHRAE 55 and 62.1 recommend these for comfort and IAC when humidity is managed properly. Question 27. In a modern context of hybrid heating systems, what is a critical design consideration when combining air source heat pumps with auxiliary gas furnaces in cold climates? A. Operating the gas furnace above the balance point to ensure efficiency. B. Avoiding simultaneous operation to reduce equipment redundancy. C. Using dual fuel thermostats to optimize economic dispatch. D. Prioritizing heat pump operation during peak electric rates. Answer. Correct answer, C. Explanation. dual-fuel thermostat shift heating source based on outdoor temperature and utility rates. This maximizes efficiency and minimizes costs. Simultaneous operation is allowed in some systems, but unnecessary if dispatch is properly configured. Ref. RA Guideline H. Question 20. By evaluating multiple motor types for an Ohu fan array, engineer Mr. Alvarez is comparing three-phase induction motors to permanent magnet synchronous motors PMSMS. Aside from efficiency, what key advantage of PMMS offer in HVAC applications? A. Reduced need for harmonic filtering in VFD applications. B. Higher torque at low speeds with better controllability. C. Lower initial costs compared to NEM-rated motors. D. Longer lifespan due to brushless commutation. Answer. Correct answer. B. Explanation. PMSMS offers superior torque and speed control, critical for modulating applications like AHAS. They outperform induction motors at partial load and integrate well with advanced controls. ASHRAE 90.1 encouraged PMMS VFA-driven systems for efficiency and control. Question 29. To determine whether a critical HVAC system is underperforming due to dirty coils or insufficient refrigerant charge, which approach offers the most definitive diagnostic insight without system shutdown? A. Visual inspection and cleaning of accessible coil surfaces. B. Logging suction pressure and ambient wet bulb temperature. C. Performing a temperature split analysis across the evaporator. D. Monitoring compressor amperage under design load conditions. Answer. Correct answer. C. Explanation. Evaporator temperature split entering versus leaving air temp reflects coil performance. Low splits indicate fouling or undercharge. Unlike suction pressure or amps, temp split directly evaluates heat transfer efficiency. ASHRAE maintenance guidelines recommend this method routinely. Question 30. The correlation between smart HVAC systems and grid interactive efficient buildings (GEBS) is gaining attention. Which feature is most essential for HVAC participation in a demand response program? A. Onboard fault detection and diagnostics (FDD). B. Ability to shift load based on utility price signals. C. Remote firmware updates from manufacturers. D. Scheduling setback temperatures during the weekend. Answer. Correct answer. B. Explanation. GEBS require smart HVAC systems that dynamically adjust operation in response to utility pricing or grid signals, e.g. open-adder. This demand flexibility is key to grid resilience, though an ASHRAE GEB initiatives emphasize load flexibility and automation.